I got 2 of.
Yeah, first test. Now I'm shocked. She said front and back. Oh, she's really early. It was the first time ever. I know I've been more than 44 hours.
Really good.
You look so alert. I know. I was some of the stuff you know we use for we need
Welcome, welcome. I'm going to go through the last week's lectures because I don't know who wrote those numbers in the PowerPoints that I had. I think I was just really too tired. But that was the peak of my worst semester time in the semester, and now I'm going downhill for load that's put on my plate. So that's the good thing. I don't think that will reappear. Alien Dr. T is not going to reappear.
Oh, that's what you said. I'm like, who's Alien Dr. T?
Alien Dr. T was here last week. I don't know who that person was. Like, I was making up numbers and putting in numbers. Like, everyone's just like, where did this 8 come from? I don't know where the 8 come from. I think I could have had my 8-year-old come in and run through those PowerPoints, and it would have made more sense. But I wanted to start off with, just clarifying everything and going through several examples to clean up some of these ideas and to kind of show you how I'm looking to grade these problems. So this is the theorem that we're using. If we have that congruence equation AX is congruent to B mod M, and D is the greatest common divisor of A and M, if D does not divide B, then there's going to be no solutions. And if D divides B, then there's going to be solutions, and exactly D solutions mod M. So I'm not going to prove this today because I'm going to spend more time with the actual how do you compute these things. And then at some time I do want to prove it for you because it's definitely doable and accessible to you. So I want to take this problem, 9x is congruent to 15 mod 24. And I'll let you copy it down because I'd like to give you a chance just to try something by yourself to make sure you got it. In this case, the A is 9, the B is 15, the M is 24, and the D is the greatest common divisor of 9 and 24. That would be 3. Hi, Joseph. How are you?
Pretty good. How about you?
I was thinking about you walking over here. You still need your test, right?
Yeah.
Yeah. This week is not as bad as last week. I don't think any of the weeks in front of me are as bad. So. The first step is to determine the number of solutions, and within this, you want to determine if there is even one solution. And so this is the check. This is the mysterious 3 divided by 15 that appeared on the PowerPoint. Why do you have that there? It's because I have to check whether the greatest common divisor divides the B. And the B in this case was 15. So 3 indeed does divide 15, and therefore we have existence of solutions. And I do know how many solutions there are going to be total. There's going to be 3 because the value of D was 3. So that's the first step. So that actually lines up how many congruence equations or solutions you need at the very end.
These solutions to mod M23.
24, yes. Got it? Make sure you take notes because I'm giving you time to take notes.
Wait, did you go back real quick? Okay.
This is the only one I'm going to go through like this. The rest of them I'm going to start going more quickly, and I want these steps lined out so you know where every little piece came from and you're able to do it yourself. Got it? Okay, your goal is to find one solution. Once you find one solution, you can find all the rest by adding a certain modulo. So you want to break down the original equation into congruence form. So this is from congruence form. So this is 9x is congruent to 15 mod 24. And you want to reduce this equation by division. So I took the 9x is congruent to 15 mod 24. I wrote down the definition. I get a linear equation. This linear equation, 9x minus 15 is equal to 24s. And that we know from when we were very little. You can divide a 3 out through the entire equation. And so you can, if you're already caught up with me, just break it down further. Divide through by 3, and you see what you get. Now, I want to point out here that when you have this 3x minus 5 is 8x, it can be rewritten back as 3x is congruent to 5 mod 8. I wanted to show you the details of where this comes from. Really, we can take every term through and divide by 3, and I would arrive right here. So I put this step in so you can see the details of why this one, and this is a reduced version of this one. And just break it down by the definition, I get this. So really, I don't need this step. I put it in here so you can see. Now, if I was looking at a time crunch, I would just start with here and then divide everything through by 3. Now you can see the relationship of why that holds. Thumbs up. We lost a terrific online classroom, a virtual classroom called Illuminate. I don't know if you know of this. I think you're too young, actually. Blackboard bought it out. But they actually had a thing on the side, so when you work with students, students can tell you when they have thumbs up or thumbs down, so you don't move on until all thumbs are up and everybody has got you at that point. It was really nice. And it was anonymous. So if you wanted to, if you had a thumbs down, no one else would see it but me. Isn't that nice?
Online.
It was everything was virtual, yeah. So we used it. I used it first for a snow day when Montclair was open and nobody could get in. We used it that day, and it was so wonderful. I think the course I was teaching was advanced calculus, something really hard. So, but then I saw this, like everything that I thought people got, half the class would be thumbs down. so I could, oh, okay, they didn't get it. I could immediately go back and backtrack. I loved it. Dr. Fernandez and I were talking about how that's gone, bought out. Okay, so now you have a new equation, a reduced equation, and I'm going to mark this as A tilde, B tilde, and M tilde because I want to refer back to them so you know which step I'm talking about. So the A tilde in this case was 3, the B tilde was 5, and the M tilde was 8. So I'm going to solve A tilde x is congruent to 1 mod M tilde. Now, some questions I got yesterday by text is that, why am I doing that? Well, I'm looking for what's called the multiplicative inverse. I'm not allowed to divide, but I am allowed to multiply. And the thing about congruences is you always come back and rotate back and eventually come back to 1, in this case, when you reduce it in this way. So if I find what can turn me back to 1, that's the thing I'm going to hit both sides of the equation by to get the coefficient in front of the x to become 1. So that's the idea. You want to move forward so the coefficient in front of the x is 1. Just like when you're little and you're multiplying both sides by the reciprocal. There just isn't a reciprocal here. It's a multiplicative inverse. It behaves like the reciprocal. So I'm looking at this reduced equation with a 1 there instead of the b. And you can solve this by listing. 3 must divide 1 plus 8s because 8 divides 3x minus 1. Or if I reduce that, I get 3x is equal to 1 plus 8s. And I can just make a list and see what s values will give me something that 3 divides. Good? Question?
Yeah, last time when we did this, we just took the, here's that B, well, the B with the line over, we just took 5, but we made the chart, so we did, your T, then for this would be 5 plus 8t, and then what goes?
Right. I
divided by
think
3.
when I did it before, first of all, I had some numbers wrong. So that it itself was confusing. And second, I didn't explain it very well. So
Okay.
I think I'm
So
putting
should
in
we not do that?
just ignore whoever was in this classroom before. They're the bad Dr. T. Just get rid of them.
Okay.
The real Dr. T is back. You can't use that excuse, by the way, on your exams and quizzes. Like today was the bad Alex and the good Alex is coming back next week. That won't work. Say it again? Yes. So you want to solve that reduced equation up there, right? There is no bad Alex. That's what he's saying. There is no bad Alex. There always is a good Alex. So look at AX is congruent to B mod M. If this was a normal algebra equation that you got when you were in 7th grade, you would just divide both sides. But you can't, right? But the idea of dividing both sides is really getting a 1 in front of that x, right? Right? That's what you do when you divide both sides. You're really trying to get that x by itself, right? So you want to make the coefficient in front of the x by itself. Since you can't divide here because you're working with integers and you're also working with congruences. You look at what will make that a tilde turn to 1. You can figure that out by solving this equation. That's going to tell you what's going to make that a tilde turn to 1 by swapping it on both sides. So watch a few steps further and you'll see why I did this. So this is what we did in class the other day. We just listed out and we found a solution. At s equals 1, I get 9, which is divisible by 3. So that tells you what turns things to 1. What turns my 3, which was my a tilde, to 1 is by multiplying by 3. The 9 is 3 times 3. So that's where I get this junk from. So just to summarize, where you are at now is you have the multiplicative inverse of 3 is 3, because 3 times 3 is 1. So you're going to slap both sides with a 3 here to turn this coefficient in front to a 1. That's the game plan. Good? Feeling is coming back into my fingers. Whew.
Wait, why is it 3 times 3?
Because I found that 9 was the solution to the mod 1 equation, and 9 is 3 times 3. So I'm knowing what will take that 3 and transform it to a 1. It's a multiple of 3. This is the reduced equation. So it was from a previous, right? I brought it back. So this, I'm just summarizing for you. This is what we have now because it was several slides back, right? So this is what we're supposed to solve. This is what I just derived. So I just copied that, so you don't need to write it down again. I labeled them equation 1 and equation 2. So I'm going to take equation 2 and multiply both sides of that equation by the thing that I found that turns things to 1, and that's 3. If I multiply both sides of equation 2 by 3, that 3 times 3 will become 1 when I mod by 8. So here's my equation 2. I'm going to hit both sides with a 3. How did I come up with that 3? By solving that formula 3x is congruent to 1 mod 8. That's where that 3 came from. That's why I know that I can put this, what to put here, what to hit both sides with. So the previous step was deriving what I have to hit both sides with to turn it into a 1. Good? Is making more sense now?
Yeah.
So I want to make this, this is the same thing as 1. 9 is 1 in mod 8. That's what my previous analysis told me, that 9 and 1 are the same thing. How do I make this a 9? I hit both sides by 3. That will make this a 9. So 9 is really 1. So this thing goes away, and I'm just left with 6. That's what I want. So that's 1 mod 8 for my previous step. So I get the 1 times x in front, and I have a solution. Notice that this 15 is larger than this 8. So it's remember all the congruence classes are boxes. So really 15 can be reduced to 7, because when I take 15 and divide by 8, I'll get a remainder of 7. So 7 is the reduced form of 15 in the box. So I just changed this 15 to 7. Yes, this 15 is larger than 8. Right? It's like looking at the number 4 when you only had the box 0 and 1. 4 went into which box when I was modding by 2? It's even, right? So it went into the 0 box. But I can also look at it as when I take 2 and divide it into 4, I get a remainder of 0. So it goes right. So when I take 8 and divide it into 15, I get a remainder of 7. So it goes in the 7 box. So when you do modding by 8, you actually have 8 boxes. You have remainders of 0, remainders of 1, 2, 3, and all. The last one is 7, right? Because when I'm at 8, I'm back to the beginning, right? So this is in box number 7. Matt, confusing?
Okay.
Yeah. I put you on the spot, so you don't mind, do you? Doing better than the last week's professor? This wasn't the only thing I did. I did all kinds of incredible. Last week was just a week of roll out the mistakes all the way through, and every document I wrote up. Everything I did. In fact, there's probably no point. I probably should have just slept. Would have helped. And I wake up Thursday morning to a medical alert. I get these medical alerts from the journals that I write in, and one of them said, sleep loss linked to brain shrinkage. That's not good. I shouldn't have shared that with you, because I know that some of you are very sleep deprived as well. So that's where that came from. 15 divided by 8 has a remainder of 7. So where are we now? We got one solution. That's 7. So we find the other solutions by adding multiples of m tilde, which was 8. So 7 plus 8 is 15. That gives me the next second solution. 15 plus 8 is 23. That gives me the third solution. I mean, that's how to find them. That's not the solution. This is how to find them. The last step is to write them in the right form. So I'll let you copy that down. Notice that I'm copying, pasting from the previous slide so you can follow. So you just have to mark up your notes to figure out, like, I'm copying and pasting, so don't copy again the same formula. Now make sense?
We had the same solutions the other week, so yeah.
Yeah, but you know, it was just so obtuse. Even I went back and looked at it, and I wrote up the notes, and I'm looking at going, I don't know why I wrote these things. So let's just not look back at that. And I didn't even post it. I went and posted this. So online already, you have this instead of last week's notes. So you're supposed to express your equations mod m. Here they are. That's how you express your solutions.
So should we ignore all the notes you did?
I think so, unless you can figure them out. I don't think there's enough detail. Huh?
The work you did in class, like that's good?
The work you did in class, I didn't hand it back to you. I'm just going to give everybody full points for being here, and then we're going to try it again today. Right? That's how you express your answer.
It doesn't matter that we're on 8 before now.
No, that's how to find them. Right? You express your answers mod 24. So there's two ways you know if you're right. One is to check whether one element, each one of these things represents boxes. So you can take one element out of the box and check if it works in your original equation. And so the easiest elements to choose are just 7, 15, and 23, right? X equals 7, X equals 15, and X equals 23. Plug them back in your original equation and see if everything works out okay.
Which original equation?
We're getting back. It's like on slide 1. It's on your notes though.
Okay.
What we started out with, we were solving 9 times x is congruent to 15 mod 24.
So we're
Something
putting-
like that, right? It was at the beginning.
We're putting the 7, 15, and 23 into the
Right, in the original equation. What you're after is that original equation. How many solutions did it have? 3. 3 mod 24. 3 different solutions mod 24. Now you're going to check whether those 3 solutions work. I just copied it, so you don't. If you didn't follow through it, this is it again. I just plugged in x equals 7 in the original equation. So 9 times 7 is 63. If I subtract 15, is it divisible by 24? Yeah, it is 24, so it's divisible by 24. So it works. Does x equals 15 work? Well, 9 times 15 is 135. 135 minus 15 is 120. 120 divided by 24, it works. 5. Perfectly divisible. If you get a decimal there, you're in trouble. You made a mistake somewhere. That's where the bad David showed up. Bad David did this. My son used to use that one all the time. That was the bad Ajay. The good Ajay's back. I left him back in that drugstore. Kids are clever. Because if I was mad at him before, I wasn't mad after hearing that. You always laugh. Say it again. Is it 48?
Yes.
Yeah, I think I only need it divisible by 24. So it's with the small things I have trouble with. Arithmetic. That's why I like mod 2. No chance of making an arithmetic error or a sign error.
I know that not every number has a multiplicative inverse on it,
That's right.
but
But this will.
can it have more than one?
No, it will not. You won't have more than one multiple. Well, the way this is set up, you won't have one once you do the division.
Not even this problem.
Yes, you will. If you're in a ring, you will. You have more. You could have more than one thing that turns you back, or you might have.
63 minus 15 is 48.
Yes.
And that's 24.
Yeah, that's what she just said.
Oh, okay.
Right. It's divisible by 24. That's what I need.
Okay.
Just scratch the 24. Say is divisible by 24. And there's the last piece. So you can check all the three that you get, and you can do it much more quickly than I'm doing here. I'm just showing you every dirty detail. So Alex, your questions are extremely interesting because you're talking about the difference between a ring and a field, the abstract algebra. Okay, so another way to check is that those numbers that you get, if you reduced properly, should be below the mod, which was 24, and you should get 3 of them because you said that you're supposed to get 3 of them. So if you got 5 of them at the end and you're supposed to get 3 of them, something went wrong. If you got 2 of them and you didn't get 3 of them, something went wrong. So that's another like mental check that you can do to make sure that your work was correct. Because I wanted to show you the rubric for Wednesday's quiz so you're very clear on how I'm looking at each of the pieces. I linked it back to the lecture so that you know what I'm talking about. But I also called it what they're supposed to be called in math terms. So either way, I'm looking for that you're actually constructively developing the solutions, not going rogue and guessing and testing or doing some hybrid version. Because each one of it's the process here that's important. It's the fact that you're looking for a multiplicative inverse and that you're actually taking that equation and working with that equation modulo m. That's what you're getting practice with. And so I'm looking for each of those pieces that we just did that, first of all, I got to be able to read it. So that's just 5 points. If I'm digging around half an hour on your quiz, that's taken away from everybody else's. So that's just a 5-point check. Then whether the solutions exist, make sure that D divides B. Clearly stated the number of distinct solutions. Calculate the D and show that there is like 3 solutions or 5 solutions, whatever there is. Reduce the equation by using the definition of congruence. That's the reduced modulos, A tilde, B tilde, and M tilde. Found the multiplicative inverse by solving A tilde is 1 mod M tilde. Alex, on this one here, you're going to get, it's not unique in the sense that you'll get another 1 modulo M. It'll cycle back to 1. It'll repeat. If you remember the Ajay list, the things were repeating as you went, so you will get more than 1 solution. But modulo inside the modulo M tilde, you'll only get 1. Then use the first solution to find the remaining solutions. These last steps are the proceeding forward. So I'm looking for each one of those pieces. So standard cut is full points off if you're just going rogue and I'm just going to guess and test and slap up some Picasso paint up there. You're on your own. The other part is if you checked your work at the end and you made a mistake somewhere else, I think that's fair. You get 5 points back somewhere. So you can't get over the full points, but you can get 5 points from just checking your work and saying, I did something wrong. I only had half an hour to work on this. I can't find it.
Do you need to explicitly state what A tilde, B tilde, M tilde is, or is it okay if we just show like the
You have plenty of time to do things. You can err on the side of writing more. And you're not going to get writer's cramp, right? Err on the side of writing more. These are questions I used to ask my sister when she was taking calculus 2. Why didn't you write more? Because I thought I was going to run out of time. Did you run out of time? No, I didn't run out of time. Then you should write more. Err on the side of writing more just to make it very clear what's going on. Like, I always had that discussion with her. That one and why did you study 3 out of 4 problems that he told you would be on the test? When you told you 4 problems will be on the test, why did you study only 3 of them? Because she's like, I didn't think he would put that one there. But he did, and he told you he would.